Hello everybody! For today's video, I am going to talk about reaction injection molding, transfer molding, and compression molding. I am going to talk about where are these molding are used and what are their advantages and what are the examples of what are the products produced with these moldings. So, let's get right to the video.
Reaction injection molding is a low-pressure, low-temperature process used to mold many types of plastic parts. This process is typically used for medical, industrial, and automotive industries. Reaction injection molding, or RIM, is often utilized for molding of strong, lightweight parts that are easily painted. The RIM process begins with polymer liquids stored in storage tanks that are eventually dispensed by high-pressure industrial pumps. The polymers are recirculated from storage tanks to a multiple-stream mix head and back to storage tanks in a continuous loop. The reaction injection molding process utilizes low-viscosity liquid polymers. These polymers expand and thicken through a variety of chemical reactions. After the polymers have been injected into the heated mold, they eventually harden. Through the RIM design process, raw materials and molding techniques can be selected and customized to deliver and desired weight, strength, density, and hardness characteristics that you are looking for. The result is polyurethane parts with much lighter weight and more intricate designs than those created by ordinary injection molding. RIM molding allows for many distinct advantages, some of which include 1. Large parts. The properties of the liquid polyurethane components enable them to fill molds for very large parts. 2. Encapsulation of inserts. Inserts of many types can be placed into a mold prior to injection of the RIM material. The RIM material can also encapsulate many inserts during molding. 3. Thick and thin walls. The RIM process offers you the flexibility to design parts with significant wall thickness variations. 4. Class A surfaces. The surface finish of parts molded with the RIM process allows manufacturers to produce Class A painted parts. Lastly, low-cost tooling options. The low injection pressures of the RIM process allow for tooling to be manufactured quicker and at lower cost than the tools used in traditional injection molding or structural form.
The common items that are made via reaction injection moldings are air spoilers, automotive bumpers, and fenders.
Compression molding is the process of molding in which a preheated polymer is placed into an open, heated mold cavity. The mold is then closed with a top plug and compressed in order to have the material contact all areas of the mold. This process is able to produce parts with a wide array of length, thickness, and complexity. The objects it produces are also high in strength, making it an attractive process for a number of different industries. Thermoset composites are the most common type of materials used in compression molding. The process of compression molding begins with the material is placed into the mold. Second, the product is heated until somewhat soft and pliable. Third is a hydraulic tool presses the material against the mold. Then, once the material is hardened and has taken shape of the mold, it is ejected. The final product will require additional work, such as cutting away the flashing. And lastly, other products will be ready immediately upon leaving the mold.
Advantages of compression molding. Compression molding is one of the least expensive ways to mass produce product due to its cost effectiveness and efficiency. This method is highly efficient, leaving little material or energy to waste. are products made by compression molding. These are ceramics and thermoset plastics such as melamine and phenolics, also fiber composites and corks.
Transfer molding is one of the many ways that engineers manufacture rubber parts. Before the process takes place, the appropriate amount of molding materials is measured, inserted and placed into the molding pot. As the material is heated, pressure forces it to transfer into the mold cavities. Transfer molding is a great way to create composite seals with insert molding, which floats in the cavity. Since cavities are independent of one another, they can move freely rather than being cut directly into the same plate. This helps to absorb variations in tolerance so the mold will stay consistent. Various inserts like plastic and metal can be used to make composite seal. These allow for multiple component sealing solution, helping reduce overall component count in assembly and providing a more robust seal. The transfer molding process. A piece of uncured rubber is placed into a portion of mold. Then, the mold is closed up and under hydraulic pressure, the rubber is forced through a small hole into the cavity. The mold is held closed while the rubber cures. Third, the plunger is raised up and the transfer pad material is removed. Lastly, mold is opened and the part can be removed. Any flash is trimmed and removed during this time. The advantages of transfer molding. 1. High cavity count. In many cases, transformed molded rubber products require few and simple preforms. One preform can still fill hundreds of cavities. This is an advantage over compression molding and can save significant amount of time in the molding process. Second, design flexibility. Transfer molding allows for sharper edges. Third, short product cycle. Transfer molding offers shorter cycle times than compression molding and can provide more consistency.
So transfer molding is very useful in producing intricate composites with plastics and metal inserts. And transfer molding's examples are gas valves, electronic circuits, and spark plugs with wires. So that's it for the video today. I hope you have learned about reaction injection molding, transfer molding, and compression molding. So thanks for watching.